Welcome everyone to Knox Game Design for July 2024. My name is Levi Smith. This month I'll be talking about exploring NES memory. So first of all, I'm going to be looking at using the FECUX emulator to look at some memory locations and values in an NES game. For this example, we're going to be looking at the original Super Mario Brothers, since most everybody is familiar with that classic game. The first tool that we're going to look at is called Cheat Search. So go back, I got the FECUX emulator already running, and you can access the Cheat Search tools and cheats, and it'll bring up this screen right here. So what we're going to be looking at is where to actually find coins in memory in Super Mario Brothers. So what I'm going to do is just going to play the game a little. 1, 2, and 3. So yeah, we got 3 coins right now. I'm going to go ahead and just pause right there. So what we can do using the cheat search, we can enter a known value right here. So let's go back over here. So we know the value of our current coins is 3. So actually you got to press reset right there, and it'll show every single memory location, all the memory values and all the locations of those in memory for this NES game. So we know our coins is 3. So and you got to remember this is hexadecimal. So 3 in hexadecimal is 3. Larger numbers you got to convert. So then we're going to press the known value. So that's what that's going to do, is that's going to filter this list of all these memory locations to every single location in memory that has a 3. So we got all these values over here that are currently equal to 3. So we still don't know exactly where the location in memory is. So what we need to do is pick up a few more coins. So jump over the pipe, watch out for the Goombas, and go down this pipe right here. So let's pick up a few more coins right here. So now we have 7 coins. I'm going to go ahead and just pause right there. So now we know our current value for coins is 7. So I'm going to change our 3 to a 7. Then click known value. So now we're just down to 2 values right here. So these are the locations in memory that are currently a 7 that were previously a 3. So if we pick up, let's go in here and pick up 3 more coins. So now we're at 10. So what 10 does, 10, we got to convert it in hexadecimal, which is 0A. So to 0A, then press known value. So now there it is. There's only one left. $. That means it's the location in memory, 075E. So that's the location in memory for the coins value. So that's kind of like what we're doing over here. So I got this here where it's showing how to do the filtering, and the slides right here. So we went down from like over 10,000 possibilities down to 16 after the first filtering, and then filtered again, and it came down to 2. And then after we filtered it the 3rd time, then it went down to that one location, 075E. And before I forget about it, there's a nice resource out there on, I forget the name of the site, but I'll put it in the notes. But it does have like already mapped out all these locations. So there is a reference for these. But if you're trying to find something on your own, or if you're looking at a game that doesn't already have a memory mapped out and a reference like that, this is a good technique to learn to do that. So what's going on? Why did we have those 2 final locations? Why was it stored at 2 locations? Well, looked into it, and what's going on is 075E is the location in memory for the actual value for comparing, like whether you're going to get a 1-up at 100 coins, and things like that. What the other one is, so 7ED and 7 EE are the binary coded decimal values that are used to display these two coin values at the top of the screen right there. So that'd be like a 1 and a 0 for that. So basically the coin values being tracked in 2 different locations. They stay in sync. We assume they stay in sync throughout the whole game. But the second one is the binary coded, which is using for displaying those values at the top of the screen. So if you change the 75E to 63, and the hexadecimal is set the current coins to 99, but the value at the top of the screen will still stay the same. So at that point, those values are out of sync. But the next time you pick up a coin, then it will play the one-up jingle, which is pretty cool. So you can actually force it to a certain point and roll over and give you a one-up. So dig a little bit deeper. So there is a hex editor in here. Close out the cheat search. Go to debug, hex editor. And what you can do here is you can go down to the value 7750. So the hexadecimal locations, memory locations are here on the left side of the screen. So we're going to go to 757. You can see some of these values still changing. 7750, and E is next to the last. E is before F. So that's currently, if you see right there, it's 0A, which is 10 in hexadecimal. So like if we go over here and like pick up 2 coins, it goes up to 12. And so now it's 0C, which is 12 in hexadecimal, which is pretty cool. So we know that's the value of coins in memory. What we can do is we can click on that value, 750E, and then add a write breakpoint to that. It'll bring up this screen right here. So when the value changes, the associated 6502 code will be displayed. So go over here, pick up another coin. So now it's instantaneously going to stop your game. And go over here and look. And what's really cool, this is the current instruction that the emulator is at, BC0C. And you can actually trace this code, which I thought was pretty cool. So what this is doing, this is incrementing INC, that memory location of the coin, 75E by 1. And then what it's going to do, it's going to load that memory, the current coins at 75E, into the accumulator. And this kind of blew my mind when I found this. So we're going to compare that with $64, and you can do the conversion. $64 in hexadecimal is 100 in decimal, and regular numbers that we're all familiar with. So what is that doing right there? So that's comparing your current number of coins with 100. Then we're going to do a branch not equivalent. So if it doesn't equal 100, we're going to like go down to BC22, line BC22, which is right here. So we don't care. So yeah, so it's going to set the, so if you reach 100 coins, we're going to store 0. We're going to store 0 at the coins location in memory. And then we're going to increment 75A by 1. And what is the load after that? But let's see here. Yeah, so if we're incrementing something by 1 after our number of coins reaches 0 or reaches 100 and gets set back down to 0, what would that be incrementing? The number of lives. That blew me away that you can. It's just that simple right here in the 6502 assembly code. I don't know. It just kind of amazed me just because I've been playing this game since I was 9 years old. And back then it's just magic. This all magically happened. But to actually see the code behind this, it just kind of amazed me right there. So that's what I have the slide on right here. So the coins is 75E, and the one, I just have a 1-up mushroom, but the location of lives is 75A. And if you go back to that reference, you should be able to 075A and find that 75A. So yeah, on screen players number of lives. So that just kind of confirms our assumption right there. So what you can also do, you can actually look at these values. So this first column here, the EE, AD, C9, D0, A9, and 8D, those are your opcodes, and these are the parameters. So EE, so we can go to that site, pagetable.com, which I talked about in a few talks ago, and bring up the opcodes for 6502, so we can verify that EE, you go down to E, and then you go down to the other E, is an INC increment. So we can confirm by this chart that EE is in fact INC. And you can do the same thing for AD, confirm that's an LDA load, and confirm that C9 is a compare statement. D0 is a branch not equivalent. So branch not equivalent's kind of like a go-to. If it doesn't equal, then go to that instruction code line down there. And then we got our load and our store right there. So yeah, that's pretty cool there. That kind of blew me away. There's some other additional tools in here. There's also a RAM search, RAM watch, debug. I always forget where the RAM search and RAM watch is. Yeah, it's under tools. So RAM search and RAM watch is under tools. So you can kind of do the same thing right here. Equal to value in memory. So we know our current coins is 12, which is 0C. So we're going to do a 0C and search, and it'll bring out those locations in memory where it equals 12. We actually got quite a few 12s in there, which is kind of interesting. I don't know if I can pick up a few more coins here. I think we're paused. So whenever it breaks, you got to press the pause button to unpause yourself. While that break is on. And unpause that. So now we're up to 50. Let's go ahead and go to 16. What is that? Unpause. I think there might actually be a way to not pause it every time. So 17. So 17. Yeah, 17. And maybe I just need to put in a 17 right there. Search. Oh, okay. So if you use the RAM search, then you can use decimal values instead of hexadecimal. So I guess that's one reason why you might want to use RAM search instead of the other screen. You can actually put them in. Now you can actually change the values signed, unsigned, and hexadecimal down there. And you can also search like 2 bytes, 4 bytes, which might be kind of helpful there. And it actually shows the current value and the previous value. We still got this breakpoint on for that, for the debugger. But if we continue on, you can see now the value is 18 and previous, and it changed by 1 right there. So yeah, just another tool if you're trying to figure out memory locations, things like that. So yeah, that's going to wrap it up for this month. Just a quick little overview of how to use FECUX to find memory location values, memory locations by value for NES games. A little bit review of 6502 assembly and how to look up values and opcodes and things like that. So hopefully everybody found it interesting, and appreciate everybody out there listening and watching.